Good afternoon, everyone, and welcome to today's SpaceX 3 Status News Conference. We are pleased today to be joined by telephone from Houston, the Johnson Space Center, Mr. Mike Suffredini, the International Space Station Program Manager. Here in Florida, Mr. Hans Koenigsmann, Vice President of Mission Assurance for SpaceX, and Mike McAleenan, Launch Weather Officer from the U.S. Air Force 45th Weather Squadron. And we will begin with opening comments from our presenters, and then we'll be happy to take questions after that. We'll start with Mr. Suffredini. Mike?
Thank you, Mike. Good afternoon, everyone. This morning we concluded our mission management team meeting in preparation for the SpaceX 3 launch. Of course, we had already determined that we were ready for the launch last week, early last week. However, Friday afternoon, one of our external MDMs failed. We call it EXT2. It controls many of the functions on what we refer to as the inboard portion of the truss, everything from the solar alpha rotary joints, the big solar array joints inboard. This includes the thermal cooling system, the solar alpha joint itself, the radiators, the mobile transporter, and a number of other systems that we had insight into. So given this particular failure of this MDM, which per our launch commit criteria is required prior to launch of any of the vehicles that we need to berth, the team had to go look at all the scenarios and see if we could figure out a way to fly the SpaceX vehicle. Of course, SpaceX is carrying on board a number of critical systems, including a new spacesuit, components to fix the existing spacesuits, a couple of very critical research experiments in the trunk, and quite a bit of logistics for our crew members on board. And so we need to get it on board as soon as we practically can. The team has spent the last 2 days looking at options to recover from this scenario. It turns out that the biggest driver for us is the positioning of the solar arrays as we look to the next failure, which is really what the concern is. This box is completely redundant with the primary EXT1 box, so today we have full functionality. However, our job is to convince ourselves that given the next failure, we could still accept the SpaceX spacecraft. And so the team has worked that. As I started to say earlier, the biggest driver was the solar arrays. You know, whenever a vehicle approaches, we have to configure the arrays such that the pluming from the thrusters as the spacecraft approaches doesn't put unnecessary loads on the solar arrays. But we also have to have the solar arrays pointed so they provide sufficient power to operate the station. And so there's always that trade we have to make when any vehicle arrives. Of course, in this case, we had to also protect ourselves for power all the way from launch of the spacecraft to the ISS, and that is indeed what the team was able to find out. Fortunately, we were in a lower beta angle over the next couple, 3 weeks, and so that provided us an opportunity to find a solar array position that will protect us. And in addition to that, the mobile transporter needs to be at work site 2 to begin the trunk ops. We will grapple the Dragon from node 2, which is not affected by this, but shortly after the spacecraft arrives, we have to get on with removing the payloads from the trunk. The first place we have to be is to have the MT out at work site 2. In addition to that, it's currently at work site 4 and in the way of any EVA to replace the EXT2 MDM. And so we will also move that in preparations for the launch. So the plan going forward is we will move the solar arrays right after launch to a position and fix them there. And then if anything occurs between launch and berthing, we will still be able to accept this Dragon spacecraft. So in that respect, we have recovered essentially the redundancy the LCC is protecting for, and we're good to go. In addition to that, then, we have to make plans to go ahead and replace this MDM, and we should do it relatively quickly whenever we can safely do that. The teams have been thinking about what suits that we would use. The plan now is to use suit 3011, which was used on previous EVA and has a new fan pump SEP that's only been exposed to a couple of EVAs, and 3005, which will get a new fan pump SEP prior to the start of the EVA. And just to quickly review the issue with the suits so that it kind of makes sense. As you know, it turns out the result of the anomaly, the cause of the anomaly was the result of contamination that was introduced by filters that were essentially meant to clean and scrub the water loops for us. Those introduced a large amount of silica into the system, and that silica eventually coagulates in the area of the fan pump SEP, and after many uses, it eventually can build up to the point where it plugs the holes, and you can't separate the water from the air, and the water then finds its way into the suit. Prior to the last contingency EVA we had to do, we changed out the fan pump SEP on 3011, which was the failed suit, and it worked fine, and we'll get a new fan pump SEP in 3005. In addition to that, we've got new filters on board that we know are clean, and in addition to that, we have over the last week, and we'll finish it up early next week. We've flushed the cooling lines and replaced the water in both the cooling lines in the station system itself and all three of the suits. So they have fresh water that have been purged to reduce significantly the amount of silica in the water today. And so we believe we're in a very good posture for the EVA. If for any reason we have a problem changing out the fan pump SEP on 3005, we have a new suit that's coming up that requires some checkout and some more work to have it ready to go, but it's a possibility. And we have a new fan pump SEP coming up on the Dragon spacecraft as well, which we could use and install in 3010, another suit that's on orbit, to have it ready. So we have many options. However, in order to preserve the opportunity to do the EVA as soon as we can after the Dragon arrives, we're going to go ahead and prep 3005, and the team believes the best suit combination for the EVA would be 3005 with the new fan pump SEP and the 3011 suit. So with that, the team concluded the MMT with a go for SpaceX 3. A go to move the MT to work site 2 this afternoon at about 3 o'clock local time, and to get the new solar array angles on board so that we can protect ourselves for the next worst failure should it occur. And the teams are marching to that direction. And that concludes my opening comments.
Okay, very good. Thank you. Hans.
Yeah, thank you. We are at a really good spot too. We worked very hard over the last couple of weeks to get ready to launch. The launch is currently scheduled for 4:58 on Monday, 44 seconds, and the reason this is so precise is that the launch window basically is instantaneous. That is the same as it was for the shuttle, basically. But the goal is to catch the plane that the ISS flies in, and then chase it and perform the rendezvous. I do want to give you a little bit of a introduction into the timeline. When we lift off, we have the first stage of Falcon 9 burning for about 2 minutes and 40 seconds. Then we have main engine shutdown, and followed by a stage separation about 3.5 seconds later, and followed by a second stage ignition about 7.5 seconds later. The second stage engine burns for a total of close to 7 minutes. About 40 seconds into the second stage flight, it will deploy the nose cone. You might be able to catch this on the video. You got to look at the far right or left corner. I forgot which one it is, but it's difficult to see, but you can see it. And then again, about 9 minutes 40 seconds after liftoff, the second stage engine will shut down. and the vehicle is in a 325 by 325, basically essentially circular orbit with 51. I forgot the exact number. I think it's 51.54 degree inclination, exactly the same as the space station. It's deploying Dragon about 35 seconds after second stage shutdown. Dragon will move away from the second stage. The second stage will perform a maneuver to get further away from Dragon. Dragon will deploy the solar arrays. There's fairings over it, and when we deploy those fairings about 2 minutes into flight, you can see the solar arrays coming out. We have a video link to confirm that. And from then on, the mission is basically handed over to our mission control in Hawthorne. The second stage will continue to perform some secondary objectives. It will deploy P-pods. In total, there are 4 P-pods are these canisters that contain small satellites. There's 4 of them on board, and they contain a total of 3 of them contain 1 satellite, and 1 of them contains 2 satellites. And then one of the satellites actually contains very small satellites called basically femtosatellites. They are like printed circuit boards. And I believe the number was 141 or 101. These are very small satellites, basically. They will be deployed on command, and the reason it's on a special command is so that they don't spread debris in the orbit. So it's going to be a while after Dragon is gone and second stage is gone. So moving on, Dragon will perform maneuvers to basically get to a higher orbit and to be closer to the station. At about 10 kilometers out under the station, it will perform proximity operations, and that is a joint operation between SpaceX in Hawthorne and the ISS team in Houston. It's very exciting, and we will see a Dragon climbing up the arbor, which is the vertical approach basically to the station, about 30 hours with a grappling at 38 hours after liftoff. And I can tell you, I'm super thrilled that we are at the spot here where we are close to launch and ready to go.
All right. Thank you, Hans. Mike.
Good afternoon. Unfortunately, we can't launch today because it's been spectacular weather the last 3 or 4 days. Tomorrow is a bit of a transition day, and we have a couple of factors that are going to influence the weather over Florida for tomorrow. If I could have the satellite picture. You can see just in the southern part of the peninsula, by the Bahamas, that's a frontal boundary that's going to work its way back to the north over the next day and a half. That's what came through the last couple of days and has cleared out and made us some beautiful weather. Also, you can see a huge weather maker moving into the southeast U.S. That is going to be approaching the area in the center part of the Gulf, maybe in the Panhandle by launch time tomorrow. And on Tuesday, you can pretty much take that whole mass of clouds and plop it over the Florida Peninsula. It looks really bad on Tuesday, but again, I think it's going to be slow enough that it's not going to impact the launch. If we'd have the forecast up. For the forecast for launch, again, with that frontal boundary moving in from the west, I think we're going to have some instability greater than we have had the last couple of days. We've only seen small cumulus clouds, and that's going to allow the thunderstorms to perhaps grow in the central part of the Florida. And with our westerly winds aloft, that could bring some of those upper level clouds back over. So those are a threat to launch. And so the main concern is those anvil clouds streaming back over the east side of Florida over the launch pad for our probability of violation at 10%, and that's the main threat. Otherwise, weather looks pretty good. Warm temperatures remain, and again, we'll watch those increasing clouds through the countdown. If we were to delay through to Friday, the next opportunity, that frontal boundary, unlike the last one, is not going to go all the way down to the Straits of Florida into the Keys. It's going to kind of linger in Central Florida area, and that's going to give us thick clouds off and on through the next 4 or 5 days and periods of rain. So not quite as good forecast for Friday. Friday's attempt was a 60% probability violation. Flight through precipitation with those showers as well as thick clouds are all a possibility. So again, 60% chance for Friday, but it looks like overall a fairly decent shot on Monday. Thank you very much.
Okay, Mike, thank you. Now we're going to take questions. We're pleased today to be joined not only by members of the news media, but members of the social media crowd here at Kennedy Space Center. And we may also have some participants on the phone bridge. And due to the fact that Mr. Suffredini is joining us by telephone and we have 3 mics and 1 Hans, it would help if you could please address your question to whom you are asking it. Also, please wait for the microphone, and we'll start off with Marcia Dunn.
Marcia Dunn, Associated Press for Mike. Do you have any idea what happened to that MDM? Why did it fail? And for the spacewalk, what's the soonest you think you could pull that off?
Marcia, no, we don't know why it failed. We were bringing it up, and it didn't come up, and we know by the current draw that that it's not operating properly at all. So, but we don't know the root cause of the anomaly. And today we plan EVA 26 on the 22nd is our current plan, right before the 53P undock and redock plan.
Irene?
Irene Klotz with Reuters, also for you, Mike Suffredini. What would be the plan if for some reason the Falcon 9 can't launch tomorrow as far as the things that you're going to be doing to protect against another MDM failure? Does that impact the would the launch go forward then on Friday? And also, why isn't there a day available before Friday? Is that a range or an ISS issue? Thanks.
The answer to your second question is it's just the way the orbital mechanics work out, and the fact that we're trying for a rendezvous within a certain amount of time for the research. So in order to protect the amount of time it takes to rendezvous, it turns out the 18th is the next good candidate for launch. The plan today is we would continue on the preparations for the EVA and keep the solar arrays in the fixed position we're going to put them, that we had planned to put them in so that we're protected. And no, I'm sorry, I take that back. What we will do is we will keep the position we want the solar arrays to be at loaded on board, and we will not go there until the 18th. But the software is set up such that if we have the next failure, it will automatically put the arrays in the right position. And so we will wait for the SpaceX vehicle to show up and then perform the EVA. At least that's our current plan, with the 18th as the launch date. And part of the reason is there's a, I'll call it a gasket. It's not really a gasket, but that gives you the right image. It's some material that we have to affix to the bottom of the MDM. It's called Coltherm. It just allows you better heat conductivity between the MDM itself and the cold plate it sits on. And while we have some on orbit, we don't have the proper one for this particular MDM. We have a backup plan if we can't get a SpaceX vehicle there. But given the time it takes us to get ready for the EVA anyway, the plan today, at least the way we think about it today, is that we would wait till the 18th, have SpaceX launch and berth, and then we do the EVA sometime shortly after that. But we'd have to work out those details.
Bill Harwood.
Hi, Bill Harwood, CBS News for Mike. A couple of really quick ones. Who would do the EVA? Where does Orbital go if SpaceX launches on time? Which slot does Orbital end up in? And then I have one follow-up.
We will decide today who does the EVA. The Orbital guys, once SpaceX berths, we're going to send them to the other side of the beta cutout. They'll probably berth, I don't know exactly, but it's sometime after the beta cutout on the 9th. It's probably like the 12th, but we haven't finalized that yet. The birth time would be the 12th. We'll have to look at launch opportunities and things like that.
Thanks. And then one kind of philosophical question. You know, you guys have trained us successfully over the years to know how important redundancy is. And I guess my question is, what were the factors that made you decide it was more important to launch SpaceX before you did an EVA to replace the MDM? I'm just curious if there's any other details you can share about the logic of that. Thanks.
Yes, and it's good that we've trained you guys so that you make sure you ask us that each time. So essentially where we ended up, Bill, because of the beta that we're in, we're able to essentially get back the redundancy we need because we can position the solar arrays such that we're okay. The thermal control system will take care of itself. It has all of its protections. Even though we can't command it, it can still operate itself. The mobile transporter, we'd lose, but it wouldn't be as big a deal if SpaceX wasn't there. So in that respect, once we move it off of worksite 4 so we can get to the MDMs, it's not a huge deal. And then the last big system is the TARG itself. Well, we operate the TARG in a pretty much fixed position most of the time, and that's where it is today. So once you sort out those issues, you realize you have full redundancy on the thermal control system. We're going to move the MT today, and so we'll have it out of the way so we can do the EVA. And we have the solar array position that protects us for many days as if we had the next failure. Then we're in a good position as if we do have the redundancy that the LCC calls for. The reason why we want to get the SpaceX vehicle up is, as you know, we've been kind of slipping a little bit to the right while we've been consuming our resources on board. We reach skip cycle on food, which is 45 days. We reach skip cycle on food on June the 18th. So there's a certain amount of urgency to go ahead and get these vehicles on ISS, as soon as we safely can do that. And so perhaps what you're thinking is what we would consider doing is waiting with the EVA, but if we wait, you're going to go past the 18th. And then you got to find the next opportunity for SpaceX or decide that you could put orbital in. Then you have the crew rotation and the cutout. Now you're on the other side of June, and then we got all the things that have to happen in the summertime. And so things start to bunch up, and so we're just trying to fly as soon as we safely can, which is what we believe we're doing in this position.
James.
Thanks. James Dane, Florida Today. Hans, I wonder if you could discuss a little bit your plans to try to recover the first stage. How are you going to go about that? What it involves, and when you think you might be able to tell us about how it goes, if we'll see anything, and as well for Mr. Safardini, I was wondering if you could address NASA's interest in that event, although obviously not really relevant to the Dragon flight. But how are you supporting? Was there any issues from NASA's perspective about trying that and putting the landing legs on this vehicle?
Yeah, you mentioned the landing legs. We have landing legs on this vehicle, 4 of them, 25 feet tall, and I must point out that the entire recovery of the first stage is completely experimental. It has nothing to do with the primary mission here. The stage separates and then waits a while until the second stage goes far away, and then starts basically going through a sequence that is completely experimental. We are super thrilled, if the first step works overall. We're expecting 30-40% maybe. Really lowballing the probability of success here, because this is a really difficult maneuver. We have a boat downrange, and we will perform a entry burn and a landing burn. We will pretend the water is land basically, and have a touchdown of the stage. If that would happen, we would be super thrilled. If we just do a good entry burn, we would be super thrilled too. So again, the expectations aren't very high on our side, but we certainly we've been doing improvements to the recovery of the first stage in little steps, being very careful that it doesn't affect the safety and the reliability of Dragon.
Mike, did you want to address the other question?
Yes. So other than just being, space geeks and very excited about this idea and seeing it come to fruition, we have a couple of responsibilities as an agency. One is to support commercial use of space, which obviously this is working towards low-cost access to space. But the more immediate responsibility of the International Space Station program is to ensure that any modifications like this do not put the flight at risk, such that we're uncomfortable putting our payloads on the Dragon spacecraft. So our review of this was in 2 areas. One, in terms of the impact to performance. specifically worry that you don't want to take out too much of your engine out capability. Well, the added mass is very, very small when you compare that to the overall performance of the 1.1 version of the Falcon 9 vehicle, and so in that respect, there was really no appreciable impact. In addition to that, of course, we wanted to make sure that the design was such that the legs wouldn't prematurely deploy during ascent. So we looked at the system design and we're comfortable that the redundancies are there to protect them from inadvertent deploy. And then, of course, after that, it's like you said, once we're convinced that it won't affect drag and performance, then anything we can do to help out, we feel obligated to do.
Jay Barbary.
Jay Barbary with NBC. This is for Hans and you too, Mike. It looks, as things stand today, that the most likely American spacecraft to visit the space station with astronauts will be SpaceX's spacecraft. Hans, where do we stand as of this time? What has to be done before SpaceX can fly astronauts to and from the space station? What's the best guess on your time? And Mike, if you'd like to add anything, we'd like to hear from you.
So I'm acting as the launch chief engineer for this mission, and I'm super focused on this mission. In fact, I've been here for a couple of weeks now and not doing anything but work on it. So I'm not sure I can really answer the question as good as you want an answer, but I can tell you that in general, I can tell you we are proceeding on our side with our Crew Dragon program right now. We're meeting the milestones. We have a couple flight tests coming up later this year. It's going to be exciting. And I really don't know any more details in terms of what needs to be done in the long run.
You have no idea now where that might be in 2 years, 3 years, 4 years. And Mike, what do you have to see from SpaceX before you'll let them visit your space station?
All right. Well, let's see. I'll be equally unimpressive for you, Jay. We have the Commercial Crew Program, which I do not manage, is working on a process to try to get us a capability that we then can procure. In that process, we have defined our requirements for the International Space Station in order for a vehicle to come and approach ISS and carry our crew to ISS. And those requirements are in the most latest procurement that is out there that, in fact, we've received proposals for, so we're very sensitive about any conversations along those lines. But just to the extent that the International Space Station needs commercial crew capability, and we've said as an agency and an administration that that's our goal and our focus. We have provided our requirements, and we're in the process and the next step in the procurement. And we just look forward to the capability when it arrives and whoever provides it.
We'll take.
Can you give us any time frame at all? Are we talking 2 years, 3 years, 6 years, 40 years? What?
I can tell you that the next step in the process is the development contract, and they're trying to make that selection here in the fall. We assume that we will have an ability to put increment crew members on a commercial vehicle in 2018. So we've procured seats from our Russian counterparts through 2017, and we are looking forward to a commercial crew capability in 2018. Now, that's to put increment crews. You might hear some folks talk they can go earlier than that with demonstration crews and the like, and we're prepared to support that if they're ready.
We'll take one more here before we go to the phone bridge. Jason.
Jason Ryan for SpaceflightInsider.com, and this one goes out to Hans with also back up to Mike. It's a question of timing. CRS-3, SpaceX 3, has slipped, best number I have at the top of my head, I think is 6 times. And we've seen that due to the skirting issue, due to the range issue, which also delayed another launch. CRS, if memory serves, is supposed to supply services through 2016. SpaceX seems to launch about the rate of 2 to 3 times a year. Is that 2016 a hard and fast date, or is it more nebulous? If SpaceX doesn't meet the 12 missions by 2016, will there be a penalty, or will it just be extended? How does that work?
So I honestly don't know the answer to your last question, but I can tell you that the plan is not to launch 2 or 3 missions a year. And in fact, we did demonstrate over the end of the last year that we can launch basically within a month. It was a month and a day or so. So we're taking the actions to increase the launch rate dramatically, and go basically to being capable to launch within 3 weeks, 2 weeks, and always faster as time goes on. But I'm also not sure if the CRS mission really slipped that much overall. There were Dragon missions typically are a little bit more complex. I can tell you that it's a more complex spacecraft, but we equally try to increase the launch rate, being again very careful to do this in a safe manner.
Sid, I'll follow up. So we you have it right. The contract really is through 2015 to order services and 2016 to complete the provision of services. Today, the launch rate is, so we're assuming something on the order, on average, of about 3 SpaceXs and 2 orbitals a year to make that happen. The shuttle had provided so many provisions in its last 2 or 3 flights that we have been really in good shape relative to logistics for the crew. And so as we've gotten to a little more, as we try to get to a little higher tempo of flights to the International Space Station, we've been okay because of what the shuttle did for us. Today, I would tell you, we look at the rates and move things around. We will get all of our flights in, or we'll be able to get all of our flights in by 2016. However, we're also now looking at the follow-on procurements for services to the International Space Station. The plan probably is to extend the existing contract 1 or 2 years, and then have a full and open competition for the follow-on through the life of the International Space Station. That's all being sorted out today in the next few weeks. But that's kind of what the plan starts to look like.
All right, let's go to the phone bridge where we'll start off with Elizabeth Howell from Universe Today. Elizabeth?
Hi, this one is for Mike. Can you let us know where the spare parts for the MDM or the MDM itself is located on the station, and how many spares there are?
This particular spare was in the lab. It's stored in the lab, and we have, I can't tell you how many MDMs, but we have a number of MDMs on orbit in different types. So we have external MDMs and we have internal MDMs, and there's some variations between some of those, but they all use similar components. And so not only do we have 2 or 3 other MDMs on board, we also have parts so we can build up different types of MDMs. But I don't have the specifics in my head. I do know that we're pretty well protected from a spare standpoint with MDMs.
Okay, and can you also let us know what kind of similar failures have happened to this in the past, if any?
This is the first EXT MDM failure we've had on orbit.
Thank you very much.
Okay, Tariq Malik from Space.com. Tariq?
I also had a spacewalk question for Mike Zaffardini. Mike, I was just wondering if you mentioned that this was a replacement, like a spacewalk task that the crews are trained on, one of those 12. And I was just wondering if you could describe, I mean, is it something akin to just swapping out a box, replacing a circuit breaker, that kind of thing? How tricky a task is it, and how long would you expect the spacewalk to take? Thanks.
As far as the Big 12 goes, this would be one of the simplest we could do. It's what we call a 6B box, and it just refers to how we plug it in and remove or replace it. Once we move the MT, there's really no covers over it, anything. It's exposed, so it's relatively easy to get to. There's 3 bolts we have to essentially turn, 2 bolts and a microconical that you turn that kind of drives the big Acme bolt that basically unscrews it from its location. What is tricky about this one is the cold therm itself. It is likely that it's adhered to the heat exchanger, the cold plate that's on the ISS, so there will perhaps be some work involved to remove any that is stuck on the cold plate. And then, of course, to install the new one. The EVA is expected from the time we depress to from the time we go outside to the time we come back in to be about 2.5 hours. It is the only thing we plan on doing on this EVA. We're just going to go out and change out that MDM. So the current plan is 2.5 hours. So we have plenty of margin if it takes a little bit longer. In the big scheme of things, though, once we move the MT, this is one of the easier things for us to do. It's very close to the center of S0. And so the trip from the airlock to its location is fairly short.
All right, we have one more question on the phone bridge, then we'll come back here. Robert Perlman from CollectSpace.com. Robert, go ahead.
Hi, thank you. A question for Hans. I believe the Falcon is right now vertical. Can you say if late stow has already occurred, or if not, when that's going to occur? And what are the late stow items for this flight?
Yeah, it's a good point. So the late stow actually is going to begin in this afternoon. It will come. I thought actually it was coming down as we started the press conference here, and as you pointed out, the next step is going to be the late load. I'm not fully aware of all the parts that go into late load. There's going to be science payloads on there, the refrigerators, and I do know that it's a significant amount of late load. I think it's close to 1,000 pounds. So we practiced very hard over the last couple of weeks to get this done in time and be ready tomorrow morning.
Okay.
Thank you.
Back here at Kennedy Space Center.
Hi, Val Phillips for Zero G News for Mike. In respect of the connector for the MDM, you mentioned that it wasn't the one that's specific for that particular model. Is that going to cause any issues, and are you going to need to go back and kind of put the right one on?
It's not a connector. It's a material that we put on the interface to the cold plate. It's relatively thin. It looks like a gasket material if you stared at it. So it's a thin kind of gasket material. It already has some on there, so it's not thick enough. We're going to put another layer on. And we have one on orbit that we could modify if we had to. So if we just use the ones coming on SpaceX, it'll be pretty easy. It just sticks on the existing material that's already there. Probably the bigger challenge is when we remove the old MDM from its location, and as I said earlier, there's probably some adherence of this material to the cold plate outside, and we'll have to scrape it off. But in the big scheme of things, this is not a big deal. It's not like a connector or something. It's a pretty simple interface.
Patterson with cttechjunkie.com. I think you've sort of already answered this, but that cold therm, as you said earlier, the kind you need is not on the station. It sounds like it's been manifested on CRS-3. Is that a late manifest, is with late stow, or was that already intended to be sent up on this flight?
No, it's a late stow. We figured out about midday yesterday that we didn't have the right material on board. We called Boeing. Boeing called Honeywell. They brought it out to an airport where one of our T-38 jets picked it up, and then they brought it back here last night and took it to KSC this morning. It's there now and will be part of the late load later on this afternoon.
Happy to help.
Okay, Irene.
Thanks. Irene Klotz with Reuters. Two quick ones for Mike and then one for Hans. Aside from the solar array positioning and then moving the MT for unpacking the Dragon trunk, is there anything else at all that that if there was a failure of the primary MDM would impact Dragon docking, any cameras, or I assume the robot arm is fine. It's on a different system.
Not for the next failure of an EXT MDM. Now, there are other failures that can take out the EXT MDM, but we have to deal with that. Those we'd have to deal with separately anyway. But assuming no other failures, just the EXT-MDM itself, those are the things we had to do to be able to have the Dragon come in berth. And then once it's berthed, it's just part of station. We treat it the same. A little more power, but not a lot.
Thank you. And for Hans, is SpaceX still? Okay.
Sorry about that. Go ahead.
If the Falcon 9 is able to launch this week, is SpaceX still on track for the? I think it's an Orbcomm. I'm not sure. Sorry, the launch later this month. And could you run through the timeline a little bit for the restart of the first stage, and through splashdown or touchdown?
So Orbcomm, yes, is still on schedule for the end of the month. We hope we get off the ground here on the 14th. That would help us. And regarding the schedule on or the timing sequence on the first stage, I don't have the numbers in my head. There's an entry burn, which is relatively long. I want to say 7-8 minutes, and then there's a landing burn. By the time the stage is landing on the water, so to speak, roughly by the time the second stage goes into orbit. It's a very short.
Would it land kind of touch down vertically and then fall over?
Yeah, that's what we expect, because obviously it's water. Yeah.
And there'll be cameras on your ship?
There's cameras on the ship. The ship has, however, a safe distance, so that's also a reason why we don't expect necessarily footage of that.
Okay, thanks.
Okay. Interspace.net, and my question is for Hans, following up on what Irene asked.
I want to just point out what I said earlier. This is an experimental thing, and this is the attempted timeline. That's how I would call that. Yeah, just to be clearly understood.
Say all that. Will you let us see the video?
If I have a video, I mean. Yes.
My question is about the instrumentation and the communication. Is it good enough that you'll have information in real time as it's coming down, and you'll know how it's performing, or is it more an issue of you see what the result was when you have the result?
So this refers to the first stage again. Yes. So I think the important part is to collect data on these experiments and figure out if it worked well or if we have to do further improvements. I don't think it's important to have this in real time. We like to see it in real time because obviously many people worked on it and are excited about it, but it's also it's far out below the horizon, so there's technical difficulties getting data back, and that's the other side of the story basically.
Okay, we'll give the last question to James Dean.
Thanks, James Dean, Florida Today again. And Hans, if you should pull this off and get an intact recovery of the booster, I was just wondering if you could sort of lay out next steps. How soon might we see an attempt to come back to land, and just sort of what's the company's thoughts about what's realistic about a landing on land and potentially achieving that reusable booster?
So I guess it depends largely on how this experiment works out, and as I said earlier, we do this step by step. So we look at the results of this one, and then we adjust the timeline or make modifications or do basically improvements. And the overall goal is to get back to land by the end of this year. However, that's a challenge, and if we pull this off, as you say, we'd be super thrilled.
Go ahead, James.
I'm sorry, quick follow-up. But with the landing back on land, would that be done here, or could it be done other places?
So that's currently in evaluation. We're looking at different landing sites.
On the next Falcon 9 too?
Yes, I think so, but don't quote me on that. And I know I should.
We'll go ahead and take another question here from Jason as well.
Quick follow-up to Irene's question. I was just wondering if you're starting to fly commercial missions. Has any of the customers voiced any concerns about the landing legs, or they're totally on board with it, or has there been any of that kind of dynamic at play or concerns about them?
Pretty much like what Mike Saffredini said earlier. There's an evaluation on the risk basically, and we did all the right tests and all the right analysis. We provide the insight into that, and then I guess that is being approved by the customer. So this is not something that we just do. It's And
Okay. Sorry.
I'm done.
You're done? Okay. We're going to go ahead and close. The headline is SpaceX is go for launch.
Yes.
4:58 p.m. tomorrow. Our next televised event from the same room here at 2 p.m. Eastern Time will be the SpaceX Science and Technology Cargo News Conference. If anyone is willing and interested in participating by the phone bridge, please call 321-867-2468 by 1:45 p.m. Thank you very much for coming.